Hello, and welcome to the Gaming with Science podcast, where we talk about the science behind some of your favorite games.
Today we'll be talking about Pandemic by Z-Man Games. All right, everyone, welcome back to Gaming with Science. This is Jason.
This is Brian.
This is Anna.
And Yann.
Yeah, so not only do we have a special guest, we have two special guests this time today. Anna Szuecs, actually, I don't know that I can pronounce your last name, so I'll just let you two introduce yourselves.
Mm-hmm.
Okay, so I'm Dr. Anna Szuecs. My last name is Hungarian. So I'm a Swiss-Hungarian doctor. I'm doing research in mental health currently at the National University of Singapore.
And I'm Yann Boucher. I'm a French-Canadian originally, and I'm a microbiologist by training. I work on microbial evolution, infectious diseases, environmental surveillance, and whatnot.
And so you can probably guess why we have Anna and Yann on here is because this is a game about medicine and epidemiology and the spread of disease. Before we jump into the game, though, we like to do fun science facts. We always offer our guests the first opportunity. Something interesting you've learned about science lately you want to share?
Okay, I've got a scary one for you. Have you ever watched the TV show The Last of Us?
I've heard of it. I haven't watched it.
I know it exists. I know it's based on the video game.
Yeah. So the first scene of the show is the best because it's a fake interview like in the 1960s of two microbiologists. One's a mycologist, one's a virologist, and they're asking them what's most dangerous. And of course, the virologist says, okay, it's the virus that's going to kill us. There's going to be a pandemic. And the other guy, the mycologist, is not afraid of that at all. And he says it's going to be the fungi. But the virologist says it's not a fungi. They don't grow at body temperature. They only do skin infections. It's not a problem. The mycologist says, yes, but what if the world was going to get a little warmer? What would happen? The fungi would evolve to be temperature tolerant. And then what happened? We lose. So this is the best scene. You should watch it. I play it in every one of my classes.
Okay, so basically The Last of Us came about because climate change induced adaptation of parasitic fungi. You're right, that is kind of scary.
Which is actually happening for real. The new Candida auris in hospitals, the hypothesis is that it evolved tolerance to higher temperatures in marshes and then got transferred to cities and hospitals. So that's an hypothesis, but it probably has started to happen. I don't want you to lose sleep over it, or maybe you should, but...
But maybe that's like a good inspiration for a next edition of Pandemic as well.
Ooh.
Climate change as a factor, yes.
The special fungi edition.
At least 50% of infectious disease are aggravated by climate change. So there you go.
Yeah, I think we're lucky as vertebrates that fungi are not that much of a problem for us. For every other living thing, plants, any arthropod, like fungi are a major, major, major issue.
For now.
For now.
Not a problem for us, yeah?
Well, there was a recent study where they have given fungi like some like robotic legs or like a little way to move forward, and then it grew inside and actually managed to move. So, just to add a little bit to the scare.
Anna's married to a robotics engineer, so.
Very cool. We'll have to get your husband on at some point when we have the right game for that too, yeah?
Oh yeah, of course, with pleasure. He is also a big board game fan, so I'm sure there will be occasions.
Alas, we already did Robo Rally. Otherwise, that would have been perfect.
So I had one too. I was looking at a study from 2022 that showed the impact of the blackleg on human evolution.
Oh, this is so amazing.
You know the study?
I don't know that one in particular, but I have other example with cholera. Basically, the selection is so strong that the ratio of different blood groups and the Ganges delta is completely different in other countries because having a certain blood group gives you resistance to cholera. So that's just how much, infectious disease shape human population. So I'm sure the plague is similar, right?
It was similar. Yeah, they used ancient DNA. They actually sequenced the genomes of human remains from different places in Europe, both before and after the plagues had come through, found enrichments in certain genes in the post-plague population, very strong signatures in a small number of immune genes. Were then able to test those immune genes in macrophages in a test tube and showed that those were associated with effective clearing of the Yersinia bacteria. And those same genes are also associated with increased risk for rheumatoid arthritis, Crohn's disease, and other autoimmune diseases.
So they put it in a white blood cell in a test tube and found it was better able to get rid of the bacteria that causes bubonic plague.
Yep.
It's better to get rid of the disease, but it also is more likely to go haywire and attack ourselves. Is that right?
Basically. So it's always we're probably getting too far afield, but the parts of your immune system that would fight off parasites are often associated with allergies. This idea, the immune system is in and of itself can be hazardous to you when it gets out of control.
Yeah, and then things that were evolutionary advantages a few centuries ago may not be so anymore in the current situation.
Yeah, we talked about this with evolution, how evolution is not forward thinking. It reacts to what's good now.
Just about surviving the day, right? Yeah.
Yep. All right, let's start talking about Pandemic. So Pandemic was designed by Matt Leacock. It's published by Z-Man Games. It's probably, as far as I can tell, it was the first big cooperative game to really go big, at least here in the US. And if you're not familiar with that, a co-op game is one where all the players are actually working together to try to beat the game before it beats you. And so you usually either all win together or all lose together. Not surprisingly, there's usually many ways to lose and only one way to win. But Pandemic has held out pretty well. It's been out since 2008, so 16 years, the time of recording. It's number 149 on Board Game Geek, so pretty well ranked. But it's also had a bunch of spin-offs. So it's had its at least 3 legacy games, which these are ones you play over a long period of time and the game changes the more you play it. This is actually how Brian and I got together for gaming, is that we played season 1 of Pandemic Legacy, which has been holding steady at number 2 on Board Game Geek for years.
That's crazy.
I played also that first edition of Pandemic Legacy, and yeah, with some other physician friends, and we got traumatized because we lost so badly. Like in one of the later chapters, at one point, we had like a strike of unlucky rolls and card flips, and everybody just died.
Oh no.
So, that was our experience.
So aside from the legacy ones, it also has other spin-offs. There's a Cthulhu version, because there's a Cthulhu version of everything. There's one about water in Norway, not Norway, in
Netherlands, the Netherlands. I've played that one.
You can tell they've got the Pandemic engine at the core, but they're different enough that they're different games. But for this one, we are talking about just core Pandemic, the original one. And the idea of Pandemic is you've got a global map. There are 48 cities around the world divided into 4 sectors, each of which is suffering from some sort of disease. They're just 4 colors. They're not named. You've got blue, red, yellow, and black. And the idea is that you are people that work for the CDC, the Centers for Disease Control. So you start in Atlanta, Georgia, which is nice and close to home to us. And then you're going around the world trying to cure these diseases before they basically trigger a global meltdown. And so you've got to go around collecting research cards, removing diseases and treating them, trying to keep things from happening. And everyone is working together, but you have limited moves. So you've got to try to plan out how it goes well. And each player gets one of, in the core game, 7 different roles, each of which lets you do things a little bit better. So like the scientist card lets you cure a disease with 1 fewer card. The dispatcher lets you move other people at a better ratio so that you've got more mobility. My personal favorite is the quarantine specialist, who just stops disease from happening near her. That's just because I like a proactive playstyle. I like being rewarded for looking ahead and saying, that's where the problem's going to be. I'm going to set myself there. And when Brian and I played this preparation for this, that worked out. It's like I sat myself down and we prevented a few of these outbreaks, which are some of the lose conditions. So that's really it in a nutshell. Like at its basics, it's a relatively simple game. You go around the board, you collect stuff, diseases get worse. Every now and then these outbreaks that make things get worse. And one thing that we've always noticed is they did a really good job of balancing the game. It always seems that when we win the game, it's because we're only about like 2 turns from losing the game.
Yeah.
In fact, the very first time I played this, we were on our last turn. We were going to lose at the end of that person's turn, and we just happened to get the right card we needed to win. But it was a real nail-biter there.
Yeah, it's always very dramatic. It keeps your adrenaline level very high because you are always on the brink of a disaster during the whole game.
I honestly don't know how they have balanced this so expertly. I have never won a game that wasn't at least 2 turns from losing. It almost seems like it's mathematically calculated so that the number of actions that you can take, the number of cards that you have, you will always either win or lose within inches of each other, or centimeters, I suppose.
As far as gameplay, this is one of my favorite games. Like this and Robo Rally are top 2 games. I love this because I love the co-op, I love the challenge, I love the puzzle. I know some people don't like cooperative games because it's easy to get what's called an alpha gamer, where there's basically one person who tells everyone else what to do, and I know people where that's happened to them. So yeah, that's true of all co-op games though. The solution to that is you just don't play with that person.
Yeah, but because that person would also be just unpleasant to play with if it wasn't a co-op game, right? If you have an alpha player who is a sore loser and like just wants to win at all costs, then that would not be a very pleasant playmate either way.
Yeah, so advice, if you are that alpha gamer out there, just step back, maybe give advice, but the rule we always have at our table is that other people can advise, but ultimately whoever's turn it is, they get final decision.
Pandemic is interesting because it kind of predates escape room culture, but fundamentally, you're kind of doing the same thing, this idea of a cooperative puzzle solving. This is probably the game I've played the most if we're counting the legacy games, and I think we should, particularly if we count all of the spin-offs. Maybe I've played Catan more, but it's got to be pretty close.
All right, so I think that's enough about the game. The transition here, as we go from board game to science behind the board game, is that this is one that all of us have real world experience. We've all actually lived through a real pandemic. And my take home from that is that Pandemic the board game is easy mode. It is actually so much easier to fix things in the board game than it was in real life because the diseases stay put. They're not jumping borders. So apparently only the players are actually using airplanes. Everyone else has shut down all air and sea travel. And like the diseases, you got 4 of them, but we can take care of them. And like they outbreak in this city, but some cities never get touched. And it's like, no, COVID showed us once it gets going, if it's communicable, it goes everywhere. And so this is where I want to hand it off to our experts and ask, like, how good a job does this go of showing? Like, how do we compare Pandemic the board game to Pandemic the horrible situation we lived through a few years?
It is a big difficult, but one of the things, for example, in pandemic, there's also it's easier to eradicate a disease than it is in real life. We only have ever eradicated one disease, smallpox. We came close to measles, but because of anti-vaccine sentiment and also because of COVID, because vaccination campaign stopped, we didn't manage to. Could we do it in the future? Probably, but we haven't eradicated many diseases, right? So that's one thing that's harder in real life than in the game. But it's true the containment aspect is easier in the game than in the real life. But then again, right? You look at COVID, and it was one of the most transmissible virus we'd ever seen, right? We didn't see that coming at all. If you take SARS-1, for example, the first one that happened in 2000, that was less transmissible, and we managed to contain it, right? It just only went to a few countries, Canada, Singapore, China, but it didn't spread everywhere in the world. MERS is the same, right? It was extremely lethal, but not as transmissible. So it varies a lot. I think SARS-CoV-2 was an extreme in that terms of transmissibility, because it's more like the common cold, right? Or flu, very, very transmissible and spreads around the world, but just a bit more lethal, right? The really lethal disease don't tend to be as transmissible, like Ebola, for example. It's nowhere nearly as transmissible as that. So, I mean, I think they do a good job, right? But they don't cover that sort of SARS-CoV-2 pandemic that is not as lethal, but like really spreads like wildfire.
Yeah, I think it's also, what you mentioned, Jason, that this game was created way, way before we had pandemics with these type of viruses.
Right.
So probably that's also why it's a bit more optimistic maybe about like how a pandemic looks like. And it's very satisfactory in the game because you really feel like you are eradicating diseases. But also the other part of that is that you have these like handful of scientists, like everybody has a different role. They can just go to any country. There is no problem. Like there is no competition between countries. They can just do whatever they want, whatever is needed to be done to eradicate the diseases. So that's another part that's like probably overly optimistic based on what we've seen with COVID.
Yeah, I mean, the eradication is based on thousands and thousands of people and experts working together in different countries, collaborating with each other, right? So that, of course, in the game that wouldn't work, right? So that's why you play a character. But that's one big difference, like Anna saying, with the real world.
Yeah, like in the real world, it was politicians thinking about maybe attacking other countries' vaccine supplies, or I don't think that nastier part is reflected in the game.
Maybe they should add a politician card or something like that.
There is an expansion that introduces a bioterrorist, so then
right.
It's no longer fully cooperative.
The traitor.
Yeah, the traitor. Maybe that's part of the nature. It is a cooperative game, and COVID showed us that on the global scale, not everyone's cooperating. There's a lot of competition and a lot of other motivations there, and some of them have good reasons behind them. It's just there's a lot of things people have to balance. In the game, you have one goal: stop the disease. In reality, there's stop the disease, there's keep the economy going, there's don't open yourself up to your hostile neighbor, and keep a good face on the public forum, and get reelected, and all these other things that are competing with that one goal.
And it's also not putting that much weight on individual action. They all relying on the experts in the game, when in real life, actually, the person that plays the biggest role is your behavior.
Yeah, and that brings us to, so if I had to pick a specific field that this game represents, probably epidemiology, so the spread of disease. And can y'all give us a feel, like what does epidemiology cover? Like what is the nature of the field? What does it look at? What do epidemiologists do?
Okay, I can take that one. I'm not an epidemiologist per se, but I work with a lot of epidemiologists. I mean, basically, epidemiology is gathering data on multiple factors like population size, behavior of people, prevalence and incidence of diseases, and then trying to model the spread, how fast it spreads, how far it's likely to spread, and model that into the future. So the epidemiology is tracking a disease. But there's also a boots on the ground epidemiology, which is maybe a bit more like in pandemic. Like, for example, I worked with the CDC on the college cholera outbreak in Haiti in 2010. I don't know if you've heard about it, but in 2010, there was a massive earthquake in Haiti that destroyed most of the infrastructure, right? National Palace crumbled. There was millions of homeless people at that time living in tents, right? Basically a tinderbox for any infectious disease, like lots of people close together, no facilities, nothing. And then 6 months later, a cholera outbreak started, which was very strange because they had not been cholera in Haiti for hundreds of years. The bacteria wasn't there. And a real epidemiologist, Renaud Pierrot, is a French epidemiologist, actually went there, he flew there, and he gathered real data on the ground, right? He talked to people, he looked at the cases, he looked at the timing, and what he figured out is that there was this UN peacekeeper battalion that had basically arrived from Nepal a couple of weeks before the outbreak started. And there had been a cholera outbreak in Nepal. Now, normally, you have medical screening for the army before deployment, and how that managed to escape, and somebody from Nepal brought cholera to Haiti, moving with the battalion, and then it spread outside the camp, and then they later figured out that there wasn't good waste management and it went in the river. That guy put all that together by talking to people on the ground, gathering data about the timing of when the infection started and then where are the first cases happen, and gathering all that data to put together the puzzle, right? Like a detective, basically. So some epidemiology is just working in a computer at the hospital, looking at the numbers for the disease in different communities, and then the different risk factors and all that to predict who's more susceptible, how long it's going to last, how many people are going to be infected. But there's also the person on the ground that's actually gathering fact and doing detective work as to where it came from and how it got transmitted. So there's a range in epidemiology in terms of infectious disease.
And also maybe one other point here is that it's very variable how much data is available by country. And some countries report their data very openly and can gather data very, very fast. The Scandinavian countries, for example, you have national databases that will record everyone's diagnosis, like every medication that people will get from the pharmacy. So it's very easy to kind of keep track of diseases there. But then there are some countries where you get barely no data, and it's not always because they don't want to disclose it. Sometimes it's just because it's so hard to gather because they don't have the infrastructure to get fast, efficient epidemiological survey. That's also part of what poses problems sometimes when you need to eradicate a disease at a global scale, is that sometimes you don't even know where the disease is.
Yeah, I've got a good example actually. This is just some work I've done recently. So I work a lot with the CDC in the US. You were mentioning, I've got some good collaborators and friends there. And we look at the disease vibriosis. So this is the disease when you can eat oysters or seafood, get gastroenteritis, or you swim and you have a wound and then get an infection and you can get necrotizing fasciitis. For those that don't know what it is, Google it. It's pretty disgusting.
That sounds disgusting.
Is that flesh-eating bacteria?
Yeah, basically, Vibrio vulnificus. So they're all under the umbrella of this vibriosis because it's similar species of bacteria that cause it. And in the US, there's the best reporting system in the world, no equal. It's a reportable illness. Every hospital is gonna send their data to the CDC. They have beautiful data, like very detailed. There's even one case where a guy was doing windsurfing and he got struck by lightning and his hands were burned. He fell in the water and then he got an infection of Vibrio vulnificus, that flesh-eating disease in his hand. So it goes into that details.
Oh, that poor guy.
He rolled multiple ones, multiple crit fails.
That guy's story could be a 1-hour discussion in itself.
So they have other ones that I can't talk about on radio, other cases of infections. But here in Singapore, for example, where Anna and I are, nobody cares about vibriosis. So I was very curious because usually these diseases are more frequent. The warmer the water temperature is, the more cases there are. And in the US, it's climbing because of climate change. So I was like, why isn't everybody dying of this here? The water is always like 28, 32 degrees. Everybody should be getting infections.
That's 28 to 32 degrees Celsius for our American listeners.
Yeah, sorry, I don't speak Fahrenheit.
That's like 90 degrees Fahrenheit, roughly.
Yeah, thanks for translating.
Basically, it's like a warm bath. You don't get refreshed going in the ocean here. So I went knocking on the doors of every single hospital in Singapore and gathered the data one by one, signed an agreement with each hospital. It was a lot of work. And then we figured out, actually, nobody talks about it, but it's 3 times the incidence in Singapore that there is in the US, which makes sense to me. And Hawaii is the state in the US where it's the highest. And it makes sense because the water's warmer, right? So data availability, for example, in Southeast Asia where we are, it's appalling. I mean, Singapore is one of the richest countries. So they have the data, but they don't always collect it. But a lot of our neighbors actually don't have the money to collect that data. So it could be a huge problem. We just wouldn't know about it, right?
I remembered hearing something. So one of the symptoms of COVID-19 infection was loss of sense of smell. So one of the data points that people realized you could use to correlate with outbreaks was the number of 1-star reviews for Yankee candles, these very strongly scented candles. Just like, this candle doesn't smell like anything. No, you just don't have a sense of smell right now.
Oh, that's hilarious.
That's so cool.
It's so funny what you can extrapolate from data, if that type of data.
Even though I'm sure there are a few confounders, like your mental health state and things like that. Like, oh, this candle is not relaxing at all, not working.
So one of the simplifications in Pandemic is, of course, you've got this global map with all these nodes connecting the different cities. I've actually argued to Jason before that this might almost be a geography game as much as it is anything else. I can tell you it was helpful for me to learn where certain cities and places were. But I suppose another real simplification is every one of those cities is treated identically. Every one of those cities, when they hit the same thing, the same infection point, that's when they'll outbreak the surrounding one. So there are a ton of nodes on the map, but there's no differences between them in population, in infrastructure, and anything like that. Obviously, that's not true.
Yeah, for sure. And also, like we saw with COVID that people travel around way more than the way these cities are connected. So it's not like, Ho Chi Minh is only connected to, I don't know, Taiwan, whatever. I guess that, when you design this type of game, you also have to make some compromises because, even though widespread air travel was already a thing 15 years ago, yeah, there are some things that you just cannot capture in the dynamic because it's always a trade-off between having it hyper realistic and having it like enjoyable and well balanced.
And I'd always say I'd rather take a fun game that makes some compromises on reality than an accurate game that compromises the fun.
Yeah, you want to kind of like tune that metaphor appropriately based on what you're trying to achieve. And you can go up and down that scale like a lot.
Now, epidemiology is studying how diseases spread. How do diseases spread? So in Pandemic, all you do is you draw a card and there's suddenly a cube appearing on the board. But in reality, like I think people are familiar with COVID, like it goes through the air and through droplets. But what are the vectors we have? What are the methods that diseases spread among human populations that we have to watch out for when we're trying to control diseases?
So I would say there's a few main categories, right? The airborne transmission is one, right? Crowded spaces, travel. But another one, for example, it could be the diseases that are carried by mosquitoes, right? Talking about dengue, malaria. So all these diseases that are viruses that are inside mosquitoes and then you get infected when they bite you, right? So these, how they transmit is the mosquito population has to be a specific species of mosquitoes that can carry that particular parasite or virus. And when the climate changes, let's say it gets warmer, the mosquito expands its zone where it can live, that particular species, and then the disease spreads with it. Sometimes people can carry them in their blood, travel, get bitten by a local mosquito, and then that can be transmitted to someone else. But usually the disease doesn't stay because it's not super compatible with local mosquito population. But sometimes it can take hold. If the local mosquito population is compatible with that disease, then it can take hold. But it's much harder to transmit that way. So it's mostly through change in climate, these type of vector-borne disease. Then there's the waterborne disease, and that's probably one of those that we know the least about, how it's transmitted. Cholera, for example, how does it move? Most of the cholera strains originate from the Ganges Delta and they circulate there. It's endemic. And then regularly it gets exported to other countries in Africa and Southeast Asia and other places when they don't necessarily have a great sanitation, so it can take hold in the population because of waterborne disease. And how they get carried over there, we don't know. Probably an individual carrying it that's symptomatic and then that introduces it in a new place. But there's also a hypothesis that ocean currents can carry it. There's some evidence that some strains, of these Vibrio cholera could travel from Asia to North American and South American coast through ocean currents. Hasn't been proven yet, but is a possibility, or through ship ballasts, or through also seafood that get transferred to the seafood industry. Let's say you have a mussel farm or oyster farm and you bring some oysters from Japan, you could breed a disease that way. So there's lots of ways like that. So it depends on how the disease is transmitted, whether it's airborne, waterborne, or vector-borne, right? How the outbreak is.
Another factor I read about is that how much time that pathogen can survive outside of any organism. So if it can survive a very long time, there is a much higher likelihood it will reach the next organism.
Yeah, like Clostridium tetanii, this is a very old disease, right? Tetanus. But we're all vaccinated against it. But actually, it's a spore-forming bacteria, right? So the spores are really hard to kill. You can boil them. They're in dead bird carcasses everywhere. That's how they spread. They float in the air. There's very little you can do, right? And the only way is to vaccinate us so we don't keep dying of getting infected by tetanus. So yeah, there's some that are tougher than others, that's for sure.
Yeah, these endospores that you get from Clostridium, that you can get from some bacillus, they are the most resilient biological structures that we are aware of. They can survive massive insults of radiation, chemistry, heat. Actually, the entire process of sterilizing, the discovery of how to sterilize things with an autoclave, for instance, is based on being able to kill these spores from these specific groups of organisms. They're really important in the history of microbiology.
Yes, these are right up there with the tardigrades for the most resilient organisms organisms. So these are the type of bacteria I studied in my PhD, were these spore-forming bacilli, and I still love them because like they form these little spores and they're just little tanks. They can survive anything. And Brian, I'm going to say this is why they beat the gram negatives. They can form these spores.
Well, okay, sure.
Is this going to be a bacteria battle now?
Brian and I have a rivalry.
I'm going to root for the gram negatives here. They got an outer membrane. They're tough too.
Yeah. I'm definitely a proteobacteria guy myself.
Okay, so before we completely lose our audience on this little tangent among the microbiologists. So you got a few ways diseases spread. How about where do new diseases come from? So some diseases like have been around forever, and then some of them just kind of like pop in. Like, so COVID kind of popped in out of nowhere. And so where do we pick up new diseases from?
Most of them come from animal, because the disease that can survive in human is because they are adapted to living at 37 degrees and being happy inside a body. So they get transferred from other animals, especially mammals, but also some others. So for example, the SARS-CoV-2 you're mentioning, this comes from bat populations that carry viruses. So it's not from nowhere, right? Bats have these viruses circulating for hundreds of years, right? It's just how does it get to human? That's called a zoonosis, when it makes a transfer, when it becomes able to reproduce in the human. That's when you get in trouble. And sometimes it's just temporarily, and then it infects some humans and it goes away. But sometimes it's maybe for good, like SARS-CoV-2, right? Maybe it's here to stay. Or the common cold, right? Then they become adapted to humans and now they do human to human transition. But usually they always originate from other animals in the first place. The AIDS virus is the same thing. It used to be chimpanzees, gorilla. Now it's very well adapted to spread human to human, right? But they all start somewhere else.
Something that kind of important to realize is that we always hear that, the virus mutated and now it got adapted to humans. And when you don't know much about epidemiology, sometimes you just imagine this virus like, being a very mean little organism who is like, I'm going to mutate and I will infect humans. But it's not really targeted to anything. Like viruses and like microbes always mutate. Like they are just like, they keep on mutating. And most of the mutations don't make them viable or don't give them any advantage. And then sometimes in some specific circumstances, there can be a mutation that actually confers some advantage to that specimen. Like for example, if something is in a bat, a virus, and mutates, and that bat is in close contact with humans, and that specific mutation makes it just more compatible with humans, then all the circumstances are aligned for that thing to just cross the barrier between the species.
If we were all vegetarian, we didn't use animal poop to fertilize our crops, there would be a lot fewer infectious diseases because most of them come from animals. The plant bacteria, they don't do anything to us. We're too different from plants.
We're going to be talking about COVID a lot this episode because that is the pandemic we've all lived in. But I am curious, there have been other pandemics, ones that have gone through human populations. And how bad was COVID-19 relative to historical pandemics? Like it sucked for all of us going through it, but like in perspective, how bad was it?
So I recommend this book by Carl Harper. He's an historian of infectious disease, and he talks about the different plagues in history. And this book is just shocking. It's called Plagues Upon the Earth. And you look at smallpox and the plague you were mentioning earlier, how many people it was killing. It's completely insane. Sometimes 50%, 60% of the population dying from the disease year after year, decade after decade. I mean, compared to this, SARS-CoV-2 is not that serious. The smallpox and the plague, horrendous and lethal disease. And now the only reason why we don't have them around anymore is because smallpox were able to vaccinate against it and eradicate it. The plague, well, it's easily treated with antibiotics, but that's not the reason it went away. We don't actually really know why it went away.
That's reassuring.
It's linked to fleas and rodents, right? The rodents are some that carry the fleas that bite you, transmit the plague, but we don't really know exactly why, right? There's still a little bit of plague around, but not much.
But even the Spanish flu was terrible. Like it was a bit overshadowed by World War I, but still, like the number of victims there was just horrendous.
I seem to remember hearing that the flu killed more people than the war did, actually. Is that right?
Yeah, I think so. That's also what I read. It's just that, the two things are, when people are already like, they already are weakened by war and the starvation and whatever, then yeah, maybe it's also, they're not in the best of states to resist any infection.
And wasn't it actually called the Spanish flu because Spain was not participating in the war, so they were bothering to report and record info? Like it was happening everywhere. It didn't come from Spain. They just got blamed because they were talking about it.
If I remember right, the first report was actually on an American military base. But yeah, it got named the Spanish flu, which is why we don't name diseases after locations anymore, because people use them to cast blame.
Yeah, I think there were things that were like considered PC back in the early 20th century and are not anymore.
What I want to know is, what did we learn from COVID-19? I've been figuring that people are going to be crawling over all the data from COVID-19 because this is the first pandemic where we had a ton of information. We're in the information age. There was tons of websites and data gathering and genome sequences. People are going to be crawling over this for decades. What did we learn? Like, what actually worked to slow the disease and what was maybe a good attempt, but it turned out not to be very important?
There's two main things that come to my mind. First of all, masks can work really well. And I think people in Asia knew that already because where we live here in Asia, when you're sick, you wear a mask because you don't want to infect other people. I remember after the pandemic, I was at a bus stop and there was three French guys. It's a lot of French people in Singapore. I don't know why. Three French guys talking to each other. Oh yeah, the mask, they didn't do anything, right? We don't really know if that works. I'm like, dude, how many times did you get sick in the last 3 years? For me, it was a big fat zero. And usually I get like the flu 3 or 4 times. So that's one of the big ones. I mean, that might not be the case for all different, illnesses, but certainly the airborne ones is going to help. We learned that without a doubt. And the other thing is vaccine technology. Like mRNA vaccine is going to change the landscape massive. And that works. And it's much quicker to make vaccines using mRNA. So you're going to see a lot of vaccines coming out. So to my mind, these are the two biggest things.
Yeah, I think there are also an increasing awareness of certain epidemiological concepts that can be helpful for future pandemics, such as like the flattening the curve theory, that if people protect themselves and don't infect others, then hospitals don't get overwhelmed, and actually you can just use your healthcare resources better, even if it means that you will need to use them over a longer time.
And also looking at wastewater, that is a really good way to look at what diseases are circulating in population. We've actually been doing that in a lot of countries for polio for a very long time, but didn't get that much attention. But now it's very clear. If you want to see, a disease that you're not necessarily picking it up or it's coming back from having a very low level, looking at wastewater is an amazing way to track.
And I think that, something that's close to my heart, I think there was a really huge increase in the awareness about mental health needs of people, both children and adults. And the number of publications about mental health in all kinds of populations really skyrocketed during COVID. And even in countries where mental health was not really something they were doing research on previously.
Yeah, and I wanted to talk more about that because of being your specialty, because people obviously got a lot of that. In fact, our fun science fact last episode was about how video games boosted people's mental health during the pandemic. So what did we get on the mental side of COVID-19 then?
Well, several things. There were good things and bad things. First, some of the good things. For example, it has been shown that people could be sometimes more effective if they were working from home and they were undergoing less stress. For example, pregnant women had less miscarriages during COVID because they could work from home, which kind of shows that, sometimes people are really overworking themselves, and being able to maybe manage your time more flexibly can help with that. Something that was not as good is that they also showed that it was important for children to have social interactions for their development. And then some of the generations that started their school life during COVID then had some adjustment issues because it was really difficult then to come back to like real life socialization after having everything virtually. Yeah, and also, there were lots of things about social isolation and then how to overcome that. And I think with COVID and like the booming industry of online connection opportunities, right? Like social media, but also several platforms to connect to others and online games you can play with people remotely and things like that. First we realized that people were social beings and needed socialization, but then also now we have more solutions to that. And I think that will also benefit some layers of the population that are more vulnerable. For example, mental health patients who sometimes have a hard time socializing in environments where most people would socialize because they are very self-conscious or they feel stigmatized. And now they have also more options thanks to the developments that happened during COVID.
Jason, do you remember we switched our monthly family gamings to online gaming during lockdown? We were playing Jackbox games and did some online role-playing game. We opened a Minecraft server for the kids to play on so that they could get to be kids.
I definitely agree with the kids and the socialization, because that happened with all of my kids. Like my oldest daughter was a freshman in high school and her freshman year was all online. And I mean, that just had downstream impacts for years. My youngest was in pre-K and trying to sit a 4 or 5-year-old down in front of a computer to do virtual school did not work.
15-minute tops, my daughter was the same.
No.
Yeah, but on the other hand, at least it's young enough, it doesn't matter at that point. It's like you can just skip a year. Okay, so getting point where we need to wrap up, but there's one last thing I want to get to, which, okay, I'm actually going to sneak in two things. One is that the news always seems to be talking about new potential things floating around. I've heard about bird flu for, I don't know how long, monkeypox, cow flu now going around. It's like, how many of these do we actually need to be worried about? And how many of them are just the news media trying to dig up something? And then related to that, kind of tying it back to the game, would it be possible to have more than one pandemic going on at the same time?
You got a lot of good questions in there. So, I mean, I'm just going to take the example of the H5N1 virus. So that's related to the flu virus. It's a different types of flu virus, right? There was lots of articles in newspapers. I don't know if you saw them. Oh, it's in the cows and it's in sea animals as well, sea mammals and everything. We're finding it everywhere around the world. So it was spreading. But was it actually jumping to humans? I think they had a handful of cases of farm workers maybe that had been affected. They're often the first people to be affected because they work closely to animals. Doesn't seem to have really made the transition, but it could. It's good to keep an eye on. And I think we're seeing a lot more because of COVID-19. We're more aware of it. There's wastewater surveillance program. People are more on the lookout, right? Mpox is the same thing, right? It's been there before. It's not the first time this comes. And there's two different groups of Mpox, one more serious. The second one, the second clade is more widespread, but not as serious. So it's all about whether these diseases are going to make the transition to humans and how likely it is to do that. It's very hard to predict that. This is why surveillance is important, to be able to pick it up early. But at the same time, it can cause a lot of worry, but when it's not necessarily warranted, right? The chances that actually going to jump is probably not that high for most diseases.
Yeah, I think the worry needs to be constructive in the way that these diseases are addressed early. So the few cases that emerge are really addressed early with help also from some countries to other countries where they are first detected. Then we are really just, decreasing the likelihood that this will be the next pandemic. But so the worry needs to be there to some level so that governments still take these diseases seriously, because we cannot just say that, the last 5 ones didn't transition to humans in any significant way, so now we are good. Any one of them can potentially do that, and the more cases there are, the higher the likelihood that they will eventually do it.
And sometimes it's silent. Like, for example, AIDS is a great example, because I remember I was really upset that they were blaming this one guy from where I'm from Quebec, and he was a flight attendant, right? It was called Patient Zero. If you ever see the movie The Band Played On, that's a great depiction of the early history of AIDS. They were blaming him as having brought the disease to the entirety of North America, right? A lot of weight to carry for one person, thousands of people dead and sick, right? But actually, they found out later on the disease had been in North America for at least 10 years before that, circulating around, silently in the population before we picked it up. So we also have to be careful about this. Sometimes the disease, SARS-CoV-2 was the same, right? It had come from China on day one. I mean, people were flying for Wuhan straight to the United States. It had been there a long time. Closing the border was futile at that point because the virus had already been there for weeks. So sometimes it goes on undetected for a while, right? And silently spread. So that's another issue with these types of diseases.
And I think that brings me to a more social point as well, that it's not like with these pandemics or infectious diseases, it's not really worth it to point the finger to other nations or other groups of people, because it can be almost anybody anywhere. And we saw that with COVID, where, in the US, some people were changing side of the road when they were like encountering someone who looked Asian. And then here in Singapore, actually, some of the Asian mothers were taking their kids away from Caucasian looking kids because the Caucasians were not wearing masks that thoroughly and were like at higher risk of infecting their kids. So, there are all these misconceptions as well. And I think for future pandemics, it will be really important to look at the facts and address the disease without pointing fingers.
Yeah, and the funny thing that happened to me related to this is when we moved in Singapore, basically when the pandemic was starting, like January 2020, and I went to the doctor because we had a really bad case of flu in the family, we weren't recovering well, and my wife tells the doctor, is like, this COVID, this new virus, he's like, oh, you're not Asian, you don't have COVID. And I'm like,
oh gosh,
how would you ever know if you only test Asian people? Like,
the doctor
you will never
said
know.
this?
Yes, literally.
Oh my gosh. Confirmation bias, institutionalized confirmation bias.
Yeah, absolutely. Yeah.
So I think this is yet another place where the game makes some simplifications. So going back, like, what about the part of the game where we've got 4 different diseases spreading not all around the world, they're each kind of geographically isolated, but could we have multiple pandemics going on, multiple global pandemics all happening at the same time? Or would the countermeasures against one just shut down all the other ones?
Well, I think there are several points here. First, that can an individual have several infectious diseases? Yes, of course they can. And also, if you know your immune system is already fighting one, actually you are at a higher risk of also getting another one. And the immune system maybe cannot be on so many fronts at the same time. So that's one point. But then also, like for diseases that are transmitted in the same way, like for example, airborne diseases, like during the COVID pandemic, I think their incidence increased, like of the other diseases.
100%.
Because because of the protection measures that were in place for COVID, and then those measures actually also worked for these other diseases like regular flu or some of these others that we usually get. But then it doesn't, those measures would not necessarily work for a disease that would be transmitted in a very different way. Like if, for example, if there would have been one that was transmitted by mosquitoes that would have caused a global pandemic, then that would have been completely separate from the airborne one.
Yeah, I mean, this is what I was talking about earlier. It comes back to transmission modes, right? The mosquito-borne diseases, I mean, I don't know if you knew that, but malaria used to be all over Europe and the United States. And it's only when we drained the swamp for farming that it went away. So it's based on the environment and where the mosquito can breed. Waterborne disease. If you build a plant to clean up the water, you're going to eliminate almost all of them all at once. But if you don't have it, I can tell you, I work in some villages in Bangladesh and we look at the infectious disease, gastrointestinal illnesses. Some people are carrying 3 or 4 at the same time. But if you provide them with clean water, that would all go away, right? So hitting every single different mode of transmission at the same time is hard. But if you hit one, you're going to hit all the diseases that are transmitted that way. But you can definitely have multiple pandemics at once. We actually have multiple pandemics going on in the world at once. We had a SARS-CoV-2 pandemic going on at the same time as cholera pandemic, and other not quite pandemic, but like dengue spreading more and things like that. There's a lot going on at once. It's absolutely possible.
I think that's also reflected in the game to some extent because one city can have hues from different colors, right?
Yeah, you have to have the right play of outbreaks happening, but yeah, it can happen.
Things have probably gone pretty bad for you if that's happened, though.
Yes.
Well, if you read these books, historically, like in Europe, for example, when they had the plague, they didn't have just the plague. They had the smallpox going on at once. They had the malaria. They had everything going on at once.
All right, so we need to wrap this up. And the way we finish this up is because we're university professors. We like giving grades to things. So we like to give the game a grade in terms of the gameplay and in terms of the science. So Brian, I'll kick this to you first. I mean, I've already made my opinion pretty much known in terms of where this ranks in my gameplay. What do you think about the gameplay?
Oh, gameplay is a clear A. I enjoy Pandemic a lot. I like playing cooperative games with Jason in particular because it means I'm not playing against him, which means it's more likely I'm going to win the game. It's fun to work as a team on these. I've noticed there's been sort of a dearth of good co-op games lately, but Pandemic's always there, and Pandemic's always fun to play. So gameplay, it's an A.
Anna, Yann, what's your opinion? And you can abstain if you want.
No, I think I would easily give it an A+.
Yeah, for playing, for sure.
Yeah, for gameplay.
Same here. One of my top games, if not the top game, and holding steady in the top 200 of Board Game Geek. So a lot of people agree. So solid gameplay. Now, what about the science? Brian and I have had conversations about what constitutes a hard science game. And I think it's fair to say that Pandemic does not exist to teach us science.
No.
It's using it to sort of wrap the mechanics of the game in, but not teach it. But I'm going to throw this to Anna and Yann. Where do you think Pandemic ranks in terms of the science content or what people might be able to learn from this?
We do kind of use grade inflation scales too here. We usually set things at a B as our starting point and we go from there.
Yeah, I think I would give it a B. I was going to say B-, but then you said those things about the inflation scale, so now I don't really dare to give it a B-. So let's say a B to B+, because there are definitely elements there, I think that, that can make people think about pandemics and disease transmission, and that's already such a good start. But then the way that these pandemics and transmissions are solved, that's not very realistic.
Yeah, I mean, I agree with that. It gives an inflated role, a sense of importance of the individual when it's really community. I think that's probably the biggest mistake it makes, right? And also how easy it is to eradicate disease probably exaggerates that a bit. And you're not going to learn about diseases because they're colors, right? So I'm going to teach you about that.
Yeah, I think I'm gonna give it a B-. And I do love Pandemic, but I think even when you look at the fact that you can take that basic Pandemic engine, that idea of sort of panicking to keep ahead of a disaster, and that's really what you can apply to a lot of different scenarios, to the Dykes in Netherland, to Cthulhu. It's got a thin veneer of science over what is a really fun engine. It's not really a science game. There's some things about this that, like the connectivity of the cities, it might be a little bit too far down the simplification scale to get a solid science grade.
Okay, so basically, very fun game. Maybe not the best to try to teach people science. I will say I'll give it a B plus for many of the reasons already said. Like, it's not meant to be a science game, so it's not surprising we don't get a lot. But I like how one person described this, and I heard this years ago, is that basically pandemic, you're playing the role of a bunch of public servants who are working together to save the world. And if there's any message I want to like teach my kids about like, hey, these are who the real heroes are, that's the one I want it to be. These are not like superheroes going and beating around bad guys. These are some guy in a lab trying to help save people's lives, or a doctor going out and treating people, or someone who's just like managing the phones and saying, hey, you need to go over here and you need to go over that way. I agree, Yann, that it emphasizes the role of the individual more, but ultimately communities are made up of a bunch of individuals, and a lot of the real heroes are these nameless, faceless people behind the scenes that are making this stuff work.
I guess it also emphasizes cooperation.
One point to consider also is that this has been made in like 15 years ago. And I think science games boomed after pandemic. We are getting more and more realistic science games. That also gamification has become a thing now. That was not necessarily something people were really looking into 15 years ago. So I think we also have to keep that in mind when evaluating pandemic and pitting it against some of the more modern games.
Yeah, because now after the pandemic, everybody knows a lot more than before the pandemic about infectious diseases. It makes my job easier as a teacher, for sure.
Yeah, and this may be a preview for some future season, but I know you two have actually made a game called Lockdown, which I assume has a lot more of the stuff we talked about in terms of actual pandemic response in it.
Very scientifically accurate.
Oh, yeah. I was going to say that we're great at criticizing other games, but then, when it comes to ours, it was also, it was not the most accurate game. It was also meant for a much younger or like more inclusive population in the way that already 7 years old could play our game. And the whole goal was to bring families or a group of friends together during the pandemic so that they can play something, even like lockdowns or other periods.
I think the best game work on multiple levels, right? So you got an easy baseline where you play, and then some people can get more information from it, and you can so these are the best ones would have multiple levels, I think.
Yeah, but I think that our game Lockdown, it was still designed with like an educational component in mind, and that component can be adapted to different groups of people. So you will use it differently when 7 years old than with university students. Like Yann uses our game in his class, and also something that can just generate some material for the lecture that is giving play the game, the icebreaker.
And even just generating curiosity, right? Like I'm sure pandemic generates curiosity about it, and people are going to go look it up on the internet, right? And try to find more information. That is very useful.
One more thing along these lines, which actually has nothing to do with the nature of the gameplay or the science, but researching for this episode, I found out that apparently Matt Leacock, who designed the game, 5% of his royalties from this game, he donates to Doctors Without Borders.
Oh, wow.
Okay.
Which,
That's
I
so
mean,
nice.
how more appropriate can you give than that? Because for those who don't know, Doctors Without Borders is an NGO, non-governmental organization, nonprofit, where their job is they send doctors around the world to treat diseases, all these outbreaks. And I'm sure they were involved in that Haitian cholera outbreak, and I'm sure they were involved in COVID all over the place.
Yeah, now you made me wonder where are where is Arkham Horror's developers' money? Like, where do they give? Where do they donate?
Sanitariums and mental health.
Hopefully. I would like to think that.
All right, well, we've got to wrap it up there. So, Anna, Yann, thank you very much. Are there any socials or any places where you want people to look you up?
Or find Lockdown.
Yeah, I guess if you can find Lockdown, that would be good. And then you can find us through Lockdown. So
You have to Google Lockdown, an educational card game, and we're not on Amazon yet. We're only in Singapore on Shopee, but if you find the game, it can be shipped to the US.
So maybe I can share the link to our distributor's website, and you can order it actually from anywhere in the world from the distributor's website.
Yeah, I'll put the link in the show notes.
Okay, that's great. All our profits go to charity as well. 100%. We're doing even better than pandemic.
Yeah, it's going to a mental health related charity called the Red Pencil that's doing art therapy with people, all kinds of people from the general population. And they did a great job during the pandemic and adapted a lot of their workshops to like online. There were things like painting with coffee and other forms of expressions that probably helped lots of people also to get out some of the negative emotions they may have feeling during COVID.
Aw, that's so heartwarming for talking about a game about horrible pandemics. All right, Anna, Yann, thanks for joining us. Thanks for talking to us about pandemic. Thanks for talking to us about lockdown and the science behind it. We're going to wrap it up here. So everybody have a good month, good games, and good fun.
And have fun playing dice with the universe.
See ya.
This has been the Gaming with Science podcast, copyright 2024. Listeners are free to reuse this recording for any non-commercial purpose as long as credit is given to Gaming with Science.
This podcast is produced with the support from the University of Georgia. All opinions are those of the hosts and do not imply endorsement by the sponsors. If you wish to purchase any of the games we talked about, we encourage you to do so through your friendly local game store. Thank you, and have fun playing dice with the universe.